Hello everyone. Welcome back to another video of the Learning Rust series. Strings in Rust often a point of confusion for newcomers, but once you grasp their underlying principles, they become incredibly powerful and safe to use. Strings are how we handle text in Rust, and while it might seem simple at first, there are quite a few details you don't want to miss. First things first, Rust has two main string types, a growable heap allocated string and an immutable string slice, usually used as a reference to some UTF-8 text. Let's start with the string type. String in Rust is implemented as a collection of bytes. These bytes are characters encoded in UTF-8. It is an owned, growable string type. That means it stores its contents on the heap. It can be modified, and it owns the data it contains. Since strings are mutable and also growable, the capacity required to store it cannot be known at the compile time. So it is stored in the heap. When a string is created, it allocates a block of memory on the heap large enough to store its initial contents. And in the stack, it stores the pointer to the allocated memory along with its length and capacity. If the string grows beyond its current capacity, it will reallocate a larger block of memory on the heap, copy the existing data to the new location, and then free the old memory. String can be declared using this syntax. Whatever is present inside the double quotes will be considered as the initial value. We can also print it using the variable, the same way we printed the other data type. Since strings are growable, we can add more details using the push and pushstr functions. Push function is used for a single character. That is why we are enclosing the comma using single quotes. To append another string to our variable, we use the pushstr function. But these functions only work on mutable variables. So we'll make the variable s mutable. Now if we print s, the entire string will be printed to the console. Since strings are UTF-8 encoded, we can use many different generic APIs for strings. We can also create an empty string by using this line, then add values to it. It will still work the same way. Now, let's look at the string slice. In Rust, a string slice is a string value that's hard-coded into the program. It's written using double quotes, just like in many other languages. The key feature is that it is immutable, which means once it's created, you can't change its contents. In contrast with the string, $str is a reference to an UTF-8 encoded string slice and does not own its data. It can point to string data located on the stack, in stack memory like string literals, or within a string on the heap. When $str points to data on the heap, it acts as a view into the heap allocated string data without owning or managing the memory itself. Let's see that in code. We can create a string slice just by assigning the string value to the variable. The data type for string slice is $str. Since this is just the reference to the string on the heap, we are using the reference symbol ampersand. And we can use this variable as and when needed, in this case, printing it. To convert a string slice into the mutable string type, we need to use the function toString. This is also a valid way to create strings. You can see after converting it to a string, now we can update the value as we need. We can also concatenate two strings using the plus symbol. Here, we are concatenating a string with the literal. Accessing an individual character using a string is also a common operation in programming. But if we try to perform this using indexing syntax in Rust, you will get an error. The reason is Rust strings don't support indexing. But why not? To answer that, in short, Unicode scalar value for a character can vary between 1 to 4 bytes. So indexing into a string by byte like this could potentially land you in the middle of a character, leading to invalid or unexpected results. Let's try to understand that in the code. We are declaring two strings, one with plain alphabets and the other with an emoji. We cannot concatenate two string literals using the plus symbol, so we are converting one into a string. Now we can concatenate them or perform other relevant operations. But what we are really interested here is to see the length of each character. You can see here the length of the alphabet is 1, but the length of the emoji is 4. This is why indexing of the bytes become inconsistent and so it is not supported. To avoid this, Rust forces you to be explicit. You can slice strings by byte ranges if you're careful, or use iterators like chars function to safely access characters. This is called string slicing. First way is by using range. This is the syntax of getting the range. The first number is the starting index of the string. Double dots or periods is the syntax to denote the range. The last number is the ending index, but it is not inclusive. So here, after slicing, index 0, 1 and 2 are selected. That is why the output is the first three characters. To include the last index, we need to add the equals symbol before the second index. Now the first four characters are selected. Another way is to use the chars or bytes function to get the iterator for characters. An iterator is an object or abstraction that lets you loop through a sequence of values one at a time. Chars or chars is to get the sequence of characters and bytes to get the individual bytes. Both of these can be iterated using next function to get data in sequence. To get the specific index, we can use the nth function and pass the index as a parameter. Both this next and nth returns option enum. We can get the value by using unwrap function. You can see result gets printed as expected. Rust provides a number of functions to manipulate strings. I'm not going to go through each of them in this video. Here are few of the commonly used ones. You can pause the video to take a screenshot and play around referring this. And let me know down in the comments which one do you like the most. That's it for this one. Let me know what you think about this series down in the comments. If you're enjoying it, give the video a like and subscribe for more. See you in the next one.